All, good evening and welcome to another session with me, Varun, on Tech Tablet. In this video, we will understand the final part of the R, which is Advanced Topics in Data Science with R. And with this, I think you would have completed the entire syllabus much in advance if you have watched all the videos properly. Okay. In this unit, we will be talking about the following topics. Okay. The first one would be forecasting with forecast. Like, what does forecasting talk to us about? What does it basically cover? Then we would be moving on to interactive plots or interactive visualization with Plotly. On the third, we have converting ggplot to interactive plots, and finally you have animations and sliders in Plotly. So these are the four topics that we would be covering in this specific unit. So firstly, the most important question, what is forecast? Okay. It is, as you can understand, I think it is predicting future values based on historical patterns. Now, please understand the words here. It is future values, which means based on certain calculations and based on certain inputs that you have, we are trying to calculate or we are trying to understand how would the future of the product vary. Okay. So in order to work on forecast, you have very specific libraries with R. That is a package called forecast. Package is a library. Okay, I hope you all remember. So when you use forecast, you have features like ARIMA. We have already discussed what is ARIMA in the previous video. Okay, auto regressive integrated moving average. Okay, so here we are trying to use PDQ parameters. I hope you remember what they are. If you do not remember what they are, go check out the previous video once again. Okay, and when you're building an ARIMA model, you would be able to forecast the data, and this would give you the output. Okay, and finally, you can also check if you know how accurate or how inaccurate your data is using the parameter accuracy. Accuracy will give you different values like RMSE, MAE, MAP. There are many other metrics involved. Again, accuracy is specifically used for categorical values. Please do not forget. Okay, while the rest is used for numerical values. Then you have some real world use cases with forecasting. Okay, here are a few examples that I've tried to list out. Now, these examples are just a few, but if you have understood the topic, then I think you can possibly build out your own examples from these use cases. So the first one is retail demand planning. Okay, so what are you doing here? Here you are trying to understand how retail workshop usually works like. Okay, for example, you can consider DMart or Walmart, any of these two. And here you have a peak season. Okay, there is a season or there is some point wherein a lot of customers buy a lot of things. And this happens especially during New Year or during any discount or during any sale times or festival periods like this. Then you have energy load forecasting. Here also, like now let us say it's the festival season, then there is a heavy requirement of power because we all have all our lights on. All these industries have all their lights on to celebrate with lights, or to keep their houses or to keep their offices bright and things like this. Then you have stock price prediction. I think this is the most commonly known algorithm to almost all of you. This is a 5-star rating importance. Okay, so here we know how Nifty or Sensex, how they all behave. How do we know how do they behave? They give us a predicted timeline of how this stock might perform after a set period of time, right? Like probably after 2 years or after 3 years or after 5 years, when you invest a certain amount, then how much would you get? How are all these made possible? It is through stock price prediction. Then you have airline passenger traffic. Okay, even here people can predict how many flyers or how many customers we would be having, and based on that they would be able to optimize their pricing, scheduling, and the fleet allocation, or probably how many services would come and go and things like these. So then you have Plotly. Now, what is Plotly? Plotly is adding more interactive features to ggplot, just to put it simple. Okay. Now, what is Plotly? It's an open source library for interactive web-based charts. Okay. Please remember, web-based charts. This word here is very, very important. Okay. And with the help of Plotly, you can also install and load. You can also, download different packages, etc. Okay, to download the package, I think the name is Plotly in itself. And once you have Plotly, you can use this function. Like when you have ggplot2, you use ggplot as the main function. Likewise, whenever you're using Plotly as a package or Plotly as a library, then you can use this function as to build a syntax. Now, if you are working on RStudio, then please notice here I have a small code that has been generated. Okay, it works beautifully if you have taken it down correctly. So do not forget to check it out on your RStudio. Put the video on pause and do have a look at it. Okay, then you have ggplotly. Okay, it converts any ggplot object into interactive plot. I think this is something that you all should use if you have used ggplot2. Then you have layout. Okay, what does layout do? It gives you the capacity to add more titles, or the names of x-axis and y-axis, define margins, and other features. And then you have subplot. Now let us say this is my R screen. Okay, like one of the screens where I would be having output. Then I would be able to very easily generate 4 plots in one final output, and that would be because of subplot. All right. Then you have our world use cases. Okay, the first one is COVID-19 dashboard. Okay. Now, when we say our real our world use cases, here you have, we are talking about Plotly library. We are not talking about any other one. So COVID-19 dashboard. Now, let us say you want to track the number of, COVID patients based on their geographic spread, or based on, male female ratio, etc. Then it needs interactive features wherein you have a drop down and you select the value and your graph changes based on the value you have selected. And in order to do this, a dashboard is very essential. The second one is a trading platform. We all know trading platforms like Bloomberg or Robinhood. There are also a lot of Indian trading platforms like Sharekhan. Okay. Now, what do we do here? We buy stocks, we sell them. There are many variants of trading: intraday. You have monthly, daily, weekly, hourly. There are many variants. Okay. Now, here when you're trading, you need to know how the stocks are performing right then. You do not have the luxury to check them out probably in another day, because the next day it's all over. I think it's better you shut the business down. So when things are so fast, then you need the information to be so accurate and at the same time dependable, right? And if it is accurate, then I think it automatically becomes dependable for any user, because that's what that is the goal of bringing in so much of technology and complexity into coding, so the real world use cases can be worked on aptly. Okay, so yeah, so this is for real time stock analysis as well. Now, there are also some real world use cases, a bit more, like genomics and bioinformatics. Okay, so researchers use Plotly to explore gene expression data with zoomable scatter plot. So because it's interactive, you can zoom into your scatter plot like 5x, 10x, and you can look across different heat maps that are generated across thousands of samples. Now, because of this, you would be able to identify if there's a relation between person X who's 1,000 years, back, and person Y who's in this generation. I mean, just imagine, it's such a wonder thing, to happen. Then you can also use it in geospatial analytics, like urban planners, wherein you would be able to see how many males or females you have, how many people are going into corporate jobs and how many are not, the crime rates, population density. There are a lot of other things that you can see with geospatial analytics. Okay. Then you have animations and sliders in Plotly. Now, what is animations and sliders? Now, there might have been windows that you would have opened wherein you have a scroller below, and as you scroll them, you would be having images which are moving from right to left or up to down. Right now, all these are called sliders. Okay, and we all know what is animation. I think in this generation, having a basic animation and knowing what animation is way too basic. Now, if you do not know what is an animation, and if you're listening to this word for the first time, then we are not talking about big movies where we are trying to show something else, like probably Spider-Man or Bahubali, where in all these movies they act in front of a green curtain, and you have scenes included. We are not talking about that kind of animation. We are talking about base level animation, where you are able to add aesthetic values, and when you click on it, you're able to have a good understandable sensible action happening. So this is what we are talking about. And when we're talking about animation, then here you have different things like animation ops. Okay, it controls the transition speed. Now let us say you have a PPT that's going, and after every 4 seconds the slide automatically changes. Okay, now this is just one small example that I've given. You have an animation slider. It adds an adjustable, draggable timeline slider, so you can look at different frames in one go. Then you have an animation button. You can play or pause different things, and then you have cumulative frames. Okay, so these frames, they accumulate points and they create a trial effect. Okay, now if you have not heard of cumulative frames, then I think this is something that you should explore and check out. It is really very interesting to watch it. And yeah, as I said, if you have not ever worked on an animation, then here is one basic variant of animation for you to practice on. All right. Then again, we have some real-time images, real-time projects on use cases with regards to how animation works or animated storytelling works. And I think the biggest example that I can give you is the COVID cases. Again, I have not mentioned it here because there might be repetition of the same things. But notwithstanding that, if you have ever looked at any government website and have tried to understand the timeline of COVID, and how it has spread from which place to which place, then there is a very beautiful animated storytelling government website that you would find. If you have never seen it, check out. You would be able to see on which date, or on which timeline the virus got spread, and in how much quantities or in what density, and from which country to which country. So you have, this is a basic variant of storytelling. Okay, so here you can see Gapminder is a famous animated bubble chart, okay, showing how GDP per capita and life expectancy evolved from 1952 to 2007. So it's a story from 1952 to 2007. Storytelling basically usually covers a period of time, and it tries to, instead of writing chunks of information, we are trying to look at it from an analytical point of view, where you have data with numbers, or with facts and figures, and these can easily be shown on the or projected on the slide. Then you have climate change visualization, wherein NASA is showing an animated time series chart of the decade by decade of the global temperatures, of the rising global temperatures. So here probably the rising temperature is indicated with redness, and you would see how the color of red changes from pink to dark red, which means the intensity of heat is multiplying. So you have things like these as well when you talk about animated storytelling with data. Urban growth mapping. We all know how cities nowadays are overpopulated, while just a decade back, cities were populated. So from populated to overpopulated, it just took a year, or 10 years span. And this can be very nicely viewed even for last 50 years, if you are able to use a good, animated storytelling library along with certain features. The epidemic spread modeling, we all know that COVID-19 is one variety of, pandemic. Likewise, we had swine flu, which is one variety of epidemic. Swine flu is epidemics, when we refer to the word epidemic, we talk about how animals have led to the spread of certain variants of viruses or bacteria or infections. And there are certain hotspots that get identified, and these are to be modeled. So that is exactly what we're doing when we're talking about epidemic spread modeling, right? So there are many other use cases like these that we can talk about when we, get into storytelling with data in our language. And I think R is one of the most effective tool or a language for us to be able to work on basic data analysis. And now let us talk about two more packages just in comparative style. You have the first one is forecast, and the second one is plotly. Now we'll just talk about each of these. Okay. Now, when we talk of forecast package, the purpose is to have a statistical time series forecasting model, while Plotly gives you interactive model. Like, there are two versions of Plotly, the first one being Plotly interactive or animated. When you talk of animated, it is usually better to work on things like showing change over time, right? Because you want to show an animation of how things have evolved from period X to period Y. But when you talk of basic interactive slides or interactive PPTs, here you just want to, ensure that when you hover or when you, scroll to certain point, you're able to see certain information without having to, again, code or, look deeper into things. So yeah, the forecast and plotly are completely meant for, different purposes. Forecast is moreover for time series analysis. Okay, while plotly is, more of a good, graph demo, graph variant of a chart for, where you can take extraordinary demos over storytelling or timeline understanding or, interactive based data visualization, just to keep it short and sweet. And I think you should try a bit of things for yourself. You all know the libraries now. Here you have the most important libraries for you if you want to work. And here are certain challenges for you. The first one is to load this data set that is NOTAM, okay? And you are expected to fit an auto ARIMA model for 12 months. You can plot it with auto plot and evaluate the accuracy. And if you're able to do this, then I would really appreciate if you have an answer and you can post it in the chat box. The second one is to convert the Plotly conversion or convert the Plotly chart. Now, when I say convert the Plotly chart, I mean convert a chart using Plotly, and the chart is ggplot2. You are free to create a chart of your choice. However, as per the task, you have scatterplot from Iris dataset. And I want you to construct the chart or the graph with ggplot2, then use ggplotly and convert it into an interactive model. And finally, the animation challenge. You can use the Gapminder dataset. All these datasets are built in RStudio, so you do not have to download them separately. So yeah, the third one is to use the Gapminder dataset and create an animated bar chart of top 10 countries by GDP per capita over time. Okay. And to use this, you could take, the help of animation slider and animation button as well. And if you've done these, do not forget to post it in the chat box, as I would be the most happiest to see, someone being able to do the exercises. In the next video, I would be posting, the lab exercises of AKNU. Okay. And I would be using RStudio directly. Okay, we would be going into coding in the next video, and after that I would be posting all the question and answers, the important question and answers as well. And yeah, with that, I think we could, completely close the session. So yeah, thank you very much. And if you enjoyed listening to all the videos, then do stay subscribed. Do not forget to, talk about this to your friends, as there is a lot more that would be coming up very soon. You all have a great day. This is, me, Varun, signing off.